Hello everyone, myself Dr. Santimay Kundu. I welcome you to this lecture of soft computing technique. This is the fourth lecture of module 3. So, till now we have covered module 1 and module 2. In module 3, we have studied fuzzy rules. We are studying fuzzy inference system, basically Mamdani, Sugeno, and Sukamoto type inferences method. Mamdani, Sugeno, and Sukamoto type inferences methods. So last class we have studied these things. So today we will try to understand the numerical examples of these methods. So please try to understand one example by Mamdani method. So we are going to discuss Mamdani methods with one example. So first is that rule one is says that if x1 is a1 and x2 is b1, then y is c1. So then let this variable is x1 here. So that is a1, this is b1, this is c1. If x1 is a2 and x2 is b2, then y is c2. So that this set is a2, this set is b2, and this is c2. And this is the outputs, that is c1 union c2. So here take one example. Suppose this value is something fuzzy set. So if I give the some value here, you will find the membership functions. So we assuming that x1 equal to 4 and x2 equal to 3. So here mu a1 x1, this is equal to 0.5, mu a2 x2, this is equal to 0.2. So we need to take the minimum value because there is and. So minimum value is 0.2. So let assume. So assume that mu c1 y equal to 0.2 and at the midpoint y equal to 6. We consider these things. This is y equal to 6. Similarly for here that mu a2x1 is 0.3, mu b2x2 is equal to 0.5. So that is the minimum. So here also we'll get mu a minimum value. So that is also 0.3. So here we will get mu c2y equal to 0.3 and let assume and consider y2. So that is y1, consider y2 equal to 8. So here the defuzzified value by the weighted average means we are taking the mid value that. So by weighted average method, so defuzzification by weighted average method, that is equal to minimum value. So 0.2 into 6, minimum value is 0.3 into 8 by 6 plus 8. So that is the value of y star. Whatever the value will get, so that is the 5 tips output. So that is the Mamdani connected with AND. A similar same example, but the rule is different. So here if x is a1 and x2 is b1, then y is c1. If x1 is a2 or, so we'll get the maximum value, and x2 is b2, then y is c2. So similarly here mu a1 x1, this value is 0.3, mu b1 x2, this is 0.5. So that is minimum value. So again mu c1 y is 0.3 and let assume we assume y equal 1, y1 equal to 6. We assume y1 equal to 6. Similarly here mu a2 x1, this is 0.5, 0.3, so it is 0.5. Okay, so take here 0. So here it is 0.5 and 0.2. So here also to take mu1 x1 equal to 0.5, mu1 x1 equal to 0.5, mu mu v1 x2 equal to 0.2. So the minimum value is 0.2. So here assume y1 equal to 6. Similarly, mu1 x1, this value is 0.3. This value is 0.3. Mu b2 x2, this value is 0.5. So here the maximum, so that will be the 0.5. So that is connected as this is connected with OR, so that the maximum value, so it is 0.5. So mu c2y equal to 0.5, assume y2 equal to some value is the mid value, so that is again 8. So here the defuzzified value z star will be 0.2 into 6 plus 0.5 into 8 by 6 plus 8. So this is the Mamdani rules connected with OR. So that is the maximum value. Next is that is Sugenu method. So that is again some rule one is that if x is a1 and y is b1, then z equal to x plus y plus 3. So Sugenu method is formula based output. So directly there is no need to use the defuzzification method. So rule 2, if x is a2 and y is b2, then z equal to x plus 2y plus 1. So both are connected with and, so we'll take the minimum value. So suppose this value is 0.5, this value is 0.3. So here we'll take 0.3 as W1. Suppose this value is 0.2, this value is 0.5. So again minimum, so we will take W2 equal to 0.3. So now as say x equal to 4, y equal to 3. So this value, suppose this x equal to 4. So this is the x, this is y equal to 4. So we get this value. So here the defuzzified value will be z, that is z star. This value will be equal to 4 into 0.3 plus 0.2 into 3 plus 4 plus 3. So that is the Sugeno method, the formula based output. Okay. So next example is the Tsukamoto method. So here rule is that if x1 is a1 and x2 is b1, then y is c1. If x1 is a2 and y is b2, then if x1 is a2 and x2 is b2, then y is c2. So this set you can say a1, this set you can say b1, this is a2, this is b2. So this is C1, this is C2. So both connected with and, so there is minimum value. So put here x equal to x1 equal to 4, x2 equal to 3. So here the value, suppose this value is 0.5, this is 0.2. So this value is 0.2, and this will be the in Tsukamoto method. This is either increasing or decreasing function, monotone function output. So here this value will get only one value here. So suppose this value z1, you can check z1 equal to, suppose this is 10 and this is also 0.1, this is 0.6. So minimum is there, so this is 0.1. So suppose z2 equal to 12. So here the Krebs output z star equal to 10 into 0.2 plus 12, minimum value is 0.1 by 10 plus 12. So we'll get the Krebs output by this method. So with this example, I hope you have understood the Haji inference method, that is Mamdani, Sugenu and Sukametu methods. So try to understand one more example. So we are using the Mamdani method. So there are three rules now. Rule 1 is that if x1 is a1 and x2 is b1, then y is c1. If x1 is a2 or x2 is b2, then y is c2. Rule 3 is that if x1 is a3 and x2 is b3, then y is c3. So here this connected with and, so here we'll take the minimum value, this connected with or, so here we'll need to take the maximum value, and this here will take the minimum value. I hope you have understood these things. So what I am saying, rule 1 will get the minimum value, in rule 2 will consider the maximum value, in rule 3 again will consider the minimum value. So have a look the fuzzy sets a1 b1 c1 and a2 b2 c2 a3 b3 c3. So these are the some fuzzy set. So there will be some value. There also membership values will get the equations of this. So here we assume this fuzzy set as A1, this is B1, this is C1, this is A2, this is B2, this is C2, this is A3, this is B3, this is C3. So this connected with and, this connected with or, so we'll take the maximum value, this is again connected with or. So assume some value here. So we are assuming some value here, that we are assuming that x equal to 12, so and y equal to 6. So here this output we are considering, this is as, this value we are considering at 0.25, this value, so this is also 0.25, so minimum, so that is also 0.25. So here if we consider, so that will be the output, this will the value of c1, this value is 0.25. Here we consider this value as 0.2, but this value is 0.5. So maximum is 0.5. So here the output, that will be the 0.5. So this height is 0.5 for the C2. Again here, and so we assuming this is 0.6, we assuming this is at 0.6, we assume this is 0.25, so we'll take the minimum value, so that is 0.25. So here the minimum value will be like that, 0.25. Okay, so now if we take the union, so the scale is defined, then you will realize that this is something like, this is something like that. So you know that is C equal to C1 union C2 union C3. So there are a number of methods. We'll get the defuzzification. After defuzzification, we'll get the value. So try to understand these things. We assume this value is something like 6. This value we are assuming 10. This value we are assuming 8. This value we are assuming 10. So here the defuzzified value, that is basically z star, you will get the value as, you will get this value as 0.25 into 6 plus 0.5 into 8 plus 0.25 into 10 divided by 6 plus 8 plus 10. So we are assuming this value as these things. Okay. Now try to understand the value. If you want to take another, so this value is 0.25. So you can write it. The value is 0.25 into 6. So z star value is 0.25 into 6 plus 0.5 into 8 plus 0.25 into 10 divided by 6 plus 8 plus 10. So this value is something like you'll get it 6 by 4 plus this will get something like 4, this will get again 5 by 2 or 10 by 4 divided by 6 plus 8 plus 10. So that is basically 6 plus 16 plus 10 by 4 into 6 plus 8 plus 10. So whatever the value, that is the value of z star. So I hope you have understood how to solve these things. Now the same thing we'll solve it by the Sugeno method. Sugeno rule is that if if x is a1 and y is b1, then z is x plus 2y plus 4. So here we took x equal to 12 and y equal to 6. So z1 is equal to 12 plus 12 plus 10. So that is basically z1 is equal to 34. z2 is equal to 2x plus y, so that is 24 plus 6 plus 5, so that is 35. z3 is x plus y, so that is 12 plus 6 plus 15, so that is 33. So now here you know that mu, the minimum value here, the value is 0.25. So here the W1 weightage is 0.25. W2 calculate from the previous case, that is 0.5, and W3 that is equal to 0.25. So here the value of Z star is uh, 0.25 into 34 plus 0.5 into 35 plus 0.25 into 33 by 34 plus 35 plus 33. So here we will get the output of Krebs output Z star. Now in Sukamoto, if the same thing as if x is a1 and x2 is b1, then y is c1. If x is a2 or if x1 is a2 or x2 is b2, then y is c2. Rule 3 is that if x1 is a3 and x2 is b3, then y is c3. So this is the value of a1, b1, c1, a2, B2, C2. This is A3, B3, C3. With proper scale, we will get the fuzzy sets. So here, this is the connection with AND. This is also the connection with OR. This is also AND. So here, as you said, this value is the output here 0.25. This is output is 0.5. Here the output is 0.25. Now this is the 0.25. So here the output in Z. So in Z you will get the value of Z1. So assume the value of Z1 here is something like 5. Something like value of Z1 is something like 5. Value of Z2, suppose it is Z2 is something like 3, and Z1 is something like Z3 is something like 6. So here the value of Z star will be, the value of Z star will be 0.25 into 5. So Z star is, the value of Z star is 0.25 into 5 plus 0.5 into 3 plus 0.25 into 0.25 into 6 divided by 0.5 plus 3 plus 6. So I hope you will get the answer is 5 by 4 plus 15 by 10, 1.5 plus 6 by 4 divided by 5 plus 3 14. So that is 10 by 4 plus 3 by 2 by 14. So whatever be the answer, you will get the value. So that is basically the value of z star. So I hope with these proper examples, I hope with this example you have understood three methods of inferences, that is Mamdani. So I hope you have understood Mamdani, Sugeno, and Sukameto method and Sukameto method. So question is that assume any uh, four fuzzy set A1, A2, B1, B2, C1, C2. The rule one is that if X is rule is that if X is AI and Y is BI, then Z is CI. So you will take the output and try to find the answer by using these methods. So these are the references of today's class. Thank you.